So today we will be wiring an Arduino to a ATMEGA 328P microcontroller, which is the same kind of chip that's on an Arduino that powers the Arduino. It's like the brains of the Arduino. Our Arduino is just a USB converter into that microcontroller, as well as a breakout board that basically takes the pins of the microcontroller and spreads them out so that you have these headers that you can plug in jumper wires to for prototyping. This is just stripping away all the prototyping and pin stuff and just sticking with the microcontroller itself, which is where all the magic happens anyways. It's just getting rid of all the ports, basically. So we're going to be connecting the microcontroller to the Arduino board so that the fully functional, ready to go Arduino board can program the microcontroller to flash its firmware and enable it to be bootloader capable. So it needs a bootloader on it. From that point, it can then receive scripts that you upload to it through USB from your computer out of the Arduino IDE, which is an integrated development environment, or a software program where you write your code for the Arduino and then you upload it to the Arduino. You can't upload code to an Arduino or specifically to the microcontroller on an Arduino board unless that chip has a bootloader. So I'm taking a naked chip that has no bootloader. I'm uploading a bootloader onto it using an existing Arduino board to upload the bootloader to a bare non-bootloader enabled ATMEGA 328P microcontroller chip. Now some people actually buy bootloader installation devices, but you can actually just use a normal Arduino board to download the bootloader onto your microcontroller. You don't need a special device for that. And the devices cost, let's say, 20-25 bucks. An Arduino board costs like $5 nowadays. The ghetto knockoff ones anyways, which are just as good as the original made by the Italian company. And it's perfectly legal. It's open source, and the Italian company does not have any problem with people making Arduino boards based on their designs. It's open source designs. And you can sell it. It's Creative Commons. So yeah, you take your $5 Arduino board that's ready to go and you use it to install the bootloader onto your microcontroller chip, and then from there you can rig up the microcontroller chip with a program by using an Arduino board that does not have a microcontroller on it and rigging it up in yet another way to your bare chip to enable the bare bones board to use its USB to serial converter to transmit the data onto your microcontroller standalone. And that way your microcontroller standalone chip will be able to get programs from your computer. So the first step is the bootloader. Once you've wired it all up and installed the bootloader using another Arduino to install it onto your microcontroller, then you wire up the microcontroller in a whole separate way in order to have it be able to download sketches from your Arduino IDE. So that will be the second step, the sketch downloading wiring. And then once we've got the sketch on there, then we'll wire up our power supply and our on-off switch and everything else to make a very bare bones microcontroller Arduino. So we don't have to have an Arduino board. It's going to be a custom Arduino development project. It's not even really Arduino at that point, though. It's technically just a microcontroller project using the same chip that's on an Arduino. But I still call it an Arduino project because technically it is using the Arduino IDE and it is using the Arduino community's knowledge to format it, or form it. And so I still see it as an Arduino, even though it's not using a traditional Arduino board. It has a smaller form factor, and it's more of a minimalist setup that I'm going for. There are no lies, mailbox. Now, let us begin. I woke up in a new Bugatti. Do I sound cool when I say that? Do I sound cooler than the original song? I would certainly hope so. Wait a minute. These aren't what I want, are they? No, these are Arduino 16-port expanders. Not to be confused with ATMEGA 328P Arduino microcontrollers. They look similar, but they're a different thing entirely. Okay. There we have it. So we're just gathering materials. We got our microcontroller. We need a 10k ohm resistor. I'll just leave out the capacitors, the inductor. Well, actually, I don't even need that right now. Let's see. 10k ohm resistor. Oh. No way. Oh no. Hey everyone, I feel so sorry for Mailbox. He thinks it's all lies, and yet he's gonna be made to look like a fool when I build the robot and fix the vacuum. He never believed in me, and he'll realize what a huge mistake that was. Let's all take a moment to feel sorry for him. It's very sad. Okay. We do have to find a 10k ohm resistor. I know. It's a pain, but somebody's got to do it. That's the one thing I wouldn't buy as a resistor kit, because I was like, I don't need that. Oh no. Oh wait, we got the capacitors. We got the quartz resonator. We're going to find the resistor. Okay, we're very close then to having everything we need here. 10k ohm resistor. Holy cow, man. What does that even look like? Mailbox woke up in a new Bugatti. Oh my gosh, guys, I found a 10k ohm resistor. I found one, baby. Now I just gotta like get a closer look at it and stuff. I feel like this is a stupid way to get parts. Oh wow, I found both. But I didn't need two though. I only needed one. Okay, so R1609. First you woke up in a new Bugatti and then you started lying to me. Mailbox woke up in a new Bugatti. Heck yeah, make you put your hands up, put your hands up. Oh my good grief, this flux is good. Dang. That's insane. Did you see that? Wow. This part never stood a chance. Guys. Kester 186 no clean flux. Are you freaking kidding me? Dude. First time ever using some real flux, not Radio Shack garbage. This is some expensive flux. And boy, what a difference it makes. This is some real flux. Thank you, Louis Rossman, for helping me find the real deal. Louis is a guy that taught me a thing or two when I was just getting started, but now I'm his teacher. I've surpassed my teacher. Everybody knows it. Even Mailbox realizes it. He's just afraid to admit it because he's a bit of a coward. He doesn't like admitting I'm Lewis's superior. Okay, I just totally... Oh! Never mind, I found the part, guys. I found it. It landed right on my crotch. This board is from a power supply. It's a power supply board for a big screen television, and it's a TV that my girlfriend Anna and I found on the side of the road, and we took it because I was like, "Baby, let's get that TV." She was like, "Really?" I was like, "Yeah, it's got a lot of parts in it that I can use for the robot. She was like, okay. So then we did it. We pulled over, we put the TV in her car, we drove it home, and went from there. Pretty much. So, yeah, I've been getting parts off that thing all the time. Okay. That's my part board, man. I feel like electronic parts are so cheap on eBay, direct order from China. I feel like it's kind of dumb to have a part board, but I'm just sticking with it anyways because, you know, getting parts in bags is one thing, but being able to find them on existing consumer electronics, there is something satisfying about that. Plus, it's forcing me to actually look at and inspect and become familiar with looking at circuit boards of consumer electronics. So I feel that pulling parts from a consumer circuit board just increases your familiarity with and comfort with working with a circuit board, as opposed to pulling it out of a bag that you ordered from China where you don't really learn anything doing that. I'm becoming more familiar with desoldering parts off circuit boards as well by using parts from a circuit board, which means I'm going to become better at doing circuit board repairs in the future because I'll have had that experience. Okay, 18 PF to 22 PF. Oof. Okay. So we got quartz resonator and our little resistor. Here's our microcontroller. This is the ATMEGA 328P. I'm facing it away from me, this little notch, because that marks the top of it. The little notch at the top is the top. And you'll see that this side doesn't have a little notch. So that's how I know that's the bottom and that's the top, because that notch. That little cutout in the top, right there. Boom. So once you can identify that, then you'll know what the pinouts are. If you've written down the pinouts of this particular microcontroller, each pin has a different function. It has 32 pins. No, it has 28 pins. Okay, so next we take an Arduino board, like so. Every consumer electronic part uses discrete components. Discrete components don't have patents. You know, a transistor, a crystal quartz resonator, these are like building blocks of electronics. If you take discrete components off of somebody else's circuit board, that doesn't make their circuit board have rights over your new circuit board. It's completely unrelated. Okay, so now we need a bunch of wire to connect everything up. So I gotta go into my wire box now. And get wires for things. Hey! Hey! Okay. So we need black wire and red wire. Pretty much that's it. And we want them to be beefy enough just to play it safe. I mean, I don't really know what size is needed, but I'd want to play it safe-ish. That's brown. You know what? Maybe I will use jumper wire. I think it would be fine, actually. We're talking about very low power consumption. Basically, these are all going to be wires where the microcontroller can communicate with ground and communicate with power in, and that's it. And the microcontroller is pulling a negligible number of amps, so you don't need a very big diameter wire. The fact that these jumper wires are what people use for prototyping Arduinos to do various Arduino projects, that tells me they'll be more than fine for this application. Hit! 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 Yeah. Okay. So I might actually use the little headers on the Arduino for this. Didn't really expect to do that. That's okay. It's kind of convenient, actually. So 5 volts. Fourth one from the right, yep. 5 volts coming off the Arduino board. Why do you think I've been productive? I'm always productive. I don't understand. And then that will go to VCC, and it will go to analog pin VCC. It's gonna fork. Okay. So I think I will make this cut. This 5-volt feed from the Arduino is going to power the microcontroller. Now, boy, do I have a surprise for you guys. Bam! Strip Master Wire Stripper. I don't know how Anna's going to feel about me having a stripper here at my house. Alone with me in my bedroom, no less. But I found the hottest stripper there is out there on the market. And I'm about to use her. to fullest advantage. Look at that. Okay. So look at that! That easy! That easy! Oh my goodness, dude! Did you see how easy that went? What the heck? Guys, man, I'm getting my stuff together now. I'm got the tools now. You guys wouldn't even recognize me if you watched my stream like a year ago. I'm becoming, you know, a real roboticist here right before your very eyes. Okay, so VCC is pin number 7. So let's count. 1, 2, 3, 4, 5, 6, 7. Can I mark it? Okay. I marked it with a little marker. Alright, helping hands time. Yeah! Alright, ha! There's like no solder on here. I assumed there was. Usually I leave solder on here. Okay. Gosh, there's way too much solder. There's way too much solder, man. Good grief. Okay, let's try this again. I have a dilemma with too much solder. Oy. Okay, we're getting it. There. Okay, we got our first component on now. I mean, our first wire soldered on. What do you guys think? I think it's pretty legit. Bad job, my butt. I ought to kick your butt for saying that. I'm the world's leading roboticist. You don't think I can solder a wire? Okay. Now we need wire to go. Alright, let me put it back in place. We need a wire to go from here. Well, let's say from, let's see, from here around to pin 20, analog pin VCC. It's not horrible, you butt. Okay. Well, I want to splice into it right here. You know, no guts, no glory. I'm gonna see if you can actually just splice just by putting this thing in the wire stripper. Didn't really work. Let me try again. Alright, I think that worked. So you just gotta score it and then strip it, and then you can pull out a tiny little there. So I expose a little bit of copper basically. And now I can tap into that. Alright. Holy cow, that's so cool. Alright, I didn't I didn't do it long enough though. Okay. Let me get the helping hands then. This is how we live. Okay. Oh, so Mailbox is here, and he does like it, huh? That's good to know. What's up, Hummingbird? I'm still wondering why your beginner YouTube video is more for advanced people. Are you referring to the C++? That was a totally beginner exercise. It just took you into like more involved algorithms, but it uses 100% all beginner concepts. Heck, I don't even use a single function. All I use is like while statements. That's totally beginner friendly. Okay. Beautiful. And then I can bring this over to here. Analog pin VCC. Okay, it is pin 20. Six from the bottom. 1, 2, 3, 4, 5, 6 from the bottom. Alright, I'm gonna mark it. 1, 2, 3, 4, 5, 6. And let's just verify from the top. It's 1, 2, 3, 4, 5, 6, 7, 8, 9 from the top. 1, 2, 3, 4, 5, 6, 7, 8, 9 from the top. Yep. So we got it marked. That is our analog pin VCC. So let's see. We'll cut it here. Wow, this is totally chill. I got everything I need for once. Like, I know I got everything now. And it's so easy because I got my diagrams already drawn. I don't have to do any research. This is all just work. I just get to work now. This is Strip Master so stupidly good. Gosh, I can never go back to like any other stripper ever. I'm in love with the stripper. Now I know why T-Pain made that song. Now I'm in love with the stripper too. What's up, Satiric? Still wondering why your beginner YouTube video is more for advanced people. You're referring to the circuit video. Which video about circuits? I don't know what video you're talking about. I mean, I got a lot of videos these days. My vid count is kind of growing. It's kind of growing out of hand here. Don't even know what I got anymore. You know, I actually have had a stripper on my lap before. It was a friend of my sister's. She came in my room. I was like 15. And she was like, oh, what's that game you're playing on your computer? I was like, it's called Counter-Strike. She was like, oh, can you show me how to play? I was like, sure. And then she just sat in my lap. I was like, whoa. I was like, what the heck? Let's just say there was some tension. And I later found out she was a stripper. She liked me. She was trying to seduce me, but I was a good boy. So we're not cool friends. She tried to make me be non-scientific. Alright, I think... Let me inspect my joint. I don't know. You know what? I'm gonna pretend both. That's, I think, the better way. You pretend the pin, pretend the wire, and then you just like snap them together. I think that's the proper way. Oh gosh, that was terrible. I feel like this is getting worse. That's gotta be it. Alright, I'll show you the final joint. There. Boom. How's that one, mailbox? Eat it. Eat it! I'm Lewis's superior! I was tossing out terms you never heard of. What? Oh Oh shoot, you're making me sound smart all of a sudden. We all know that's not true. Mailbox thinks I'm mentally retarded. Just let that sink in for a minute. That's great, Hummingbird. That's what I wanted. Other people should be able to follow along from home. Should not be an issue. Okay, so we now got power to our analog pin VCC on the right and our normal VCC on the left. The power is indicated by red. This pin will plug into our Arduino's